All right, 2.3 polynomial functions. Of higher degree with modeling. So when we're looking at higher degree in terms of like compared to what we've been doing, we're looking at cubic functions, which are degree 3. And we're looking at quartic functions, which are degree 4. A degree n polynomial, which is just, this is going to be like the generic form of a polynomial. P of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus plus a sub 2 x squared plus a sub 1 x plus a sub 0 for a sub n not equal to 0.
Why is the equal sign box?
Because the iPad does that. Anytime there's something like that, it's just because it's what the iPad does, and I can't turn it off.
Do we have to remember that?
As in, like, am I going to ask you to write it? Probably not. Could I? Yes. Just the generic form of a polynomial. It just says that basically, it's like if this was like x to the 5th, then this is going to be x to the 4th. Fill in the blank, x squared, x to the 1st, x to the 0. That's all it's saying. All right, the vocabulary of polynomials. Each monomial in this sum, meaning like this up here, a sub n x to the n, a sub n minus 1, x to the n minus 1, so on and so forth, all the way to a sub 0, is a term of the polynomial. A polynomial function written in this way with terms in descending degree, which is how it should always be written for a final answer, is written in standard form. The constants a sub n minus 1, a sub 0 are the coefficients of the polynomial. The term a sub n x to the n is the leading term. And a sub 0 is the constant term. Oh, not that. Common cubic function, so basically just like what they look like. I know we kind of had them in our 12 basic functions. But if a sub 3 is greater than 0, so that's just saying in that polynomial equation that I had, like the generic form, a sub 3, if it's greater than 0, meaning it's positive, then it will look something like this. Or it could potentially, depending on what else is going on in the function, could actually look something like this. A cubic function turns around twice. If a sub 3 is less than 0, meaning it's negative, essentially it's just reflected. And so it would look something like this, or it could be more drastic and look something like this. So then the other like big one for this section is quartic functions, so common quartic functions. So if a sub 4 is greater than 0, it can be kind of like, it'll almost look kind of flat on the bottom. If you like zoomed it in more, you would see like probably a slight little like dip or something. Or it might even look like a W where it's turning around 3 times. If a sub 4 is less than 0, so it's negative, it can be upside down. So I'll try to do this one a little better. So like this, it's still kind of flat, but it has that little dip. So that's just another visual of what you could see with that. Or it can be basically an M instead. So odd functions will always end opposite, one going positive, one going negative. Even functions will always end with both things going in the same direction. So a definition. Multiplicity of a 0 of a polynomial function if f is a polynomial function and x minus c raised to the m is a factor of f, but x minus c raised to the m plus 1 is not, then c is a 0 of multiplicity m of f. So essentially we can have like double zeros, potentially even triple zeros, depending on like what power something's being raised to. It just means that essentially it crosses that point like multiple times. zeros of odd and even multiplicity. If a polynomial function f has a real zero c of odd multiplicity, then the graph of f crosses the x-axis at C0, and the value of f changes sign at x equals c. If a polynomial function f has a real zero c of even multiplicity, then the graph of f does not cross the x-axis at C0, and the value of f does not change sign at x equals c. Then we have the intermediate value theorem. What is happening? Which will also abbreviate as IVT. And it says if A and B are real numbers with A less than B, and if f is continuous on the interval, I should specifically say on the closed interval A to B, then f takes on every value between f of A and f of B if y sub 0 is between f of A and f of B. And they have opposite signs. Then f of c equals 0 for some number c in A to B.